Hi everyone. Last time we were in class together, we worked on this three reservoirs problem. And in the three reservoirs problem, remember, we went through this iterative process in order to find out what was the flow rate through each of the pipes. And in our final iteration, the way that we knew that we were done and the solution had converged was when the F values weren't changing, or they're changing very little, less than 1% at this point. And also there's flow balance with the sum of the flow rates in equaling the sum of the flow rates out. Well, what if you're asked to find the pressure at the junction? This location in our example indicated location D. In one of your homework problems, it gives you the physical elevation of that junction and then asks you to find what's the pressure there. So remember, in our final iteration, we had our correct guess for the head at D. That is, this is the total energy there is at D. So that if you know the elevation, if that's given in the problem statement, you can rearrange what is head in order to solve for the pressure at D. So the pressure at D is going to be the head minus its physical elevation minus the velocity head multiplied by the unit weight of water. Now there's not just one velocity head, which is what makes things a little bit complicated. There's three pipes that are connected to this junction, and each one of them have a different velocity. We can see in this example there's a pretty huge disparity in the velocities through each of the three pipes. We've got one of the pipes with less than 1 foot per second and one of them with 13 feet per second. So what I like to do is find the average velocity head, and that'll have units of feet. And so the way we can do that, remember, velocity head is v squared divided by 2g. So it'll be v equals, okay, let me do this, equals v squared divided by 2 divided by g, which in traditional units is 32.2. So now I've got the velocity head for this one, and if I just drag this down, now I've got the velocity head for each of the other two as well. And so my average velocity head is 1.1 feet. And of course there's more precision there that isn't being shown. And so what is the pressure at D? So I'll do that. Pressure at D. Alright. My pressure at D is going to be the head at D that we previously calculated minus the elevation at D. And just in this illustration, I'm saying, what if the physical elevation of D is 85 feet? In your problem for the homework statement, it tells you what they want you to assume for the head at the junction, the physical elevation of the junction. Now minus the average velocity head, and then we multiply that by the unit weight of water, which in traditional units is 62.4 pounds per cubic foot. So now what we have, this is the pressure in pounds per foot squared. So that's how you find the pressure at the junction.